Last time I have given you a homework. Now we will solve second question. Write IUPAC names of the following. Now we start from this one. Now this is ether. That is, this benzene ring is attached to OCH3 group. Therefore, name of IUPAC name of this compound is methoxybenzene. Common name of this compound is anisole. Now this one. Now if we remove this NO2, then it becomes phenol. Now give numbering 1, 2, 3, 4, 5 and 6. At 2 position there is nitro group, therefore it becomes 2-nitrophenol. Now this second one. Now give numbering from the end which is nearer to the functional group. Now here there is functional group, here also functional group. Now number from this position 1, 2, 3 and 4. Now it is parent alkene is butane. Now here at 1 position there is OH group, at 3 position there is OH group, therefore it is diol. At 2 position there is methyl group, therefore it becomes 2-methyl butane 1,3-diol. Butane 1,3-diol. Methyl butane 1,3-diol. Now next, this one. Now here 1, 2, 3, 4 and 5. 5 carbon atoms in a ring structure. Therefore it is cyclopentane. At 1 position there is OH and 1 position there is CH3 group. Therefore it becomes 1-methyl cyclopentane 1-OL. Now question number first. We'll start from this cyclohexane 2En1OL. Now cyclohexane. This is cyclohexane. Now at 2 position there is En, that is double bond, and at 1 position there is OH. Now if we consider this is first position, then it becomes cyclohexanol, and at 2 position here there is double bond. This is the structure of cyclohexane 2En1OL. Cyclohexane 2En1OL. Now this pentane 1,4-diol. Pentane means 5 carbon atoms. 1, 2, 3, 4 and 5. Now at 1 and 4 position there are 2 hydroxy group. Now give numbering 1, 2, 3, 4 and 5. At 1 position there is OH group, at 4 position there is OH group. Now where is the carbon atom? Here CH2, 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 CH, CH3. This is the structure of pentane 1,4-diol. Now this one. 1-ethyl cyclohexanol. Now cyclohexanol. This is cyclohexane and cyclohexanol, that is OH group. This is 1 position, and at 1 position there is ethyl group, therefore it is C2H5. This is the structure of 1-ethyl cyclohexanol. Now this one, methyl phenyl ether. Now ether means O. At oxygen atom is attached to methyl group and vinyl group. Vinyl means CH double bond CH2 group. This is methyl, this is vinyl group, therefore it is methyl vinyl ether. Now this one, 3-methoxyhexane. Hexane means 6 carbon atom. position, 1, 2, 3, there is methoxy group, therefore it becomes OCS3. Now where is the carbon atoms? This is 1, 2, 3, 3-methoxyhexane. Hello students, last time we have started new topic, alcohols, phenols and ethers, in which we have completed introduction, then classification of alcohols, phenols and ethers, and then nomenclature of alcohols, phenols and ethers. Now we are going to see the next point, preparation of alcohols, that is general methods for the preparation of alcohols, in which first method we are going to see is from alkyl halides. Now this method we have seen in reactions of alkyl halides. Alkyl halides, when undergo substitution reaction with aqueous KOH or NaOH, gives alcohols, or when these alkyl halides are created with moist silver oxide, then also formation of alcohol takes place. These reactions we have seen in last topic, that is halogen derivatives. Now we are going to see only general reactions of these methods. This is alkyl halide RX. When it is boiled with aqueous alkali like KOH or NaOH, then here simple substitution reaction takes place and halogen atom from alkyl halide is replaced by hydroxy group, and we get here ROH plus KX. This is alcohol. Now here this halogen atom is substituted by OH minus ion to form alcohol. This is simple nucleophilic substitution reaction. Now we are going to see hydrolysis of alkyl halides using moist silver oxide. Now this moist silver oxide, that is Ag2O, when it is dissolved in water, it is converted into AgOH, twice AgOH. Therefore, reaction of alkyl halide is carried out with silver hydroxide, that is AgOH. How it is obtained? When it is dissolved in water, that is when it becomes moist. Then here simple substitution reaction takes place and halogen atom from alkyl halide is replaced by hydroxy group to form alcohol and AgX. Here halogen atom from alkyl halide is replaced by hydroxy group to form alcohol. In this way, alkyl halides converted into alcohols by using aqueous alkali like KOH or NaOH, or by using moist silver oxide. Now we are going to see second method for the preparation of alcohols is by acid catalyzed hydration of alkenes. That is, alkenes undergo hydrolysis in presence of acidic medium like concentrated H2SO4 to form alcohols. Now here this reaction we have seen in last year in hydrocarbons in the chemical properties of alkenes. Now here alkene is unsaturated hydrocarbon having carbon-carbon double bond. When this alkene is treated with concentrated H2SO4, this concentrated H2SO4 is written as HOSO3H, in which this hydrogen have minor positive charge and OSO3H have minor negative charge. Now addition of this HOSO3H takes place across the double bond of this alkene to form alkyl hydrogen sulfate. This is alkyl hydrogen sulfate. This alkyl hydrogen sulfate undergo addition of water molecule, that is hydrolysis, to form CHCOH. That is, this OSO3H group is replaced by hydroxy group, and this OSO3H group get attached to this one hydrogen atom of water to form H2SO4. Now in this reaction, alcohol is formed. That is, addition of water molecule is carried out across the double bond, but in presence of concentrated H2SO4. And here H2SO4 acts as a catalyst which is regenerated at the end of reaction. Now we are going to see the example. Now this compound is propene, CH3CH double bond CH2. Now when this compound is treated with concentrated H2SO4, then here addition of this H2SO4 takes place across the double bond of alkene. But this propene is unsymmetrical alkene. Therefore, addition of this H2SO4 takes place according to Marconi-Crobbs rule. And according to Marconi-Crobbs rule, addition of reagent takes place across the double bond of unsymmetrical alkene in such a way that negative part of the reagent goes to that carbon atom of alkene which have less number of hydrogen atom, and then this hydrogen get added across the double bond of this carbon atom, and you will get here CH3 COSO3H CH3 then this is isopropyl hydrogen sulfate, and this isopropyl hydrogen sulfate when undergo hydrolysis in presence of water molecule to form CH3 CHOH CH3 plus H2SO4. This compound is propane 2OL, propane 2OL. In this way, these alkenes are converted into alcohols by acid catalyzed hydrolysis. Now we are going to see the mechanism of acid catalyzed hydration of alkenes. That is the reaction mechanism of acid catalyzed hydrolysis of alkenes. Now it is three-step mechanism. Now here the step first is formation of carbocation intermediate. Now what is meant by carbocation? The positively charged carbon atom is known as carbocation. Now in first step, formation of carbocation takes place. Look here, this alkene C double bond C, addition of this H3O plus. Now here hydration is carried out, that is addition of H2O, and it is carried out in presence of acidic medium. Therefore this H2O becomes H3O plus by the absorption of proton to form this H3O plus ion. Now this H3O plus ion and alkene undergo reaction. How this reaction takes place? Now here the pi electrons of this alkene get attached to this hydrogen atom, and then the OH bond breaks and this bonded electron pair gets shifted on oxygen atom. Now here formation of carbocation takes place in this way. Now here this electron get attached to hydrogen atom, therefore this carbon forms bond with this hydrogen atom like this, and here this carbon becomes electron deficient, therefore there comes positive charge, and this H2O is removed in this way, and this positively charged carbon atom is known as carbocation or carbonium ion. Now this carbocation in second step undergo nucleophilic attack of H2O. Now this H2O, that is HOH, here oxygen is electron-rich species having two lone pairs of electrons. Therefore it acts as a nucleophile, and this is carbocation. Therefore nucleophilic attack of this water takes place on this carbocation, and here this intermediate is formed. Formation of this intermediate takes place, and in step 3, deprotonation of this intermediate takes place to form alcohol. Now this is second step intermediate. In third step, this intermediate is converted into alcohol by deprotonation. How deprotonation occurs? Now here addition of H2O is carried out. Now when this H2O is added, now here this proton is absorbed by this H2O, and this electron pair gets shifted on this oxygen atom, and here deprotonation occurs. Deprotonation means removal of H plus ion, and this alcohol is formed. That is, this hydrogen is separated from this oxygen as H plus ion. It is get attached to this H2O to form H3O plus, and this is alcohol. Formation of alcohol takes place. This is 3-step mechanism. Step first is formation of carbocation. Second step, nucleophilic attack of H2O, and third step, deprotonation to form alcohol. Now we are going to see third method for the preparation of alcohols by hydroboration-oxidation of alkenes. That is, here from alkenes we are going to prepare alcohols. This method also we have seen in last year or in 11th standard in hydrocarbons under the reaction of alkenes. Now here this is alkene, and when this alkene is treated with B2H6, this is diborane. Now this diborane may be written as BH3. Now here addition of this diborane takes place across the double bond of alkene in such a way that hydrogen get attached to one carbon atom of alkene and boron get attached to second carbon atom of alkene. Now here all these 3 hydrogen atoms from BH3 are replaced by 3 alkyl group, and here formation of trialkyl borane takes place like this. Hydrogen, here this hydrogen comes from this BH3, and this boron get attached to this carbon atom, and here 3 hydrogen atoms from this BH3 are replaced by 3 alkyl group, and therefore it becomes thrice B, that is trialkyl borane. Formation of this trialkyl borane takes place plus BH3. This BH3 removes as it is, and then this is first step in which formation of trialkyl borane takes place. Now this trialkyl borane in second step undergo oxidation. This oxidation is carried out in presence of hydrogen peroxide and in alkaline medium. Therefore OH minus is written here. In alkaline medium, in presence of hydrogen peroxide, oxidation of this trialkyl borane is carried out to form corresponding alcohol. But 3 molecules of alcohol are formed, and plus DOH thrice. In this way, alcohols are formed by using this hydroboration-oxidation of alkenes. Now we are going to see fourth method for the preparation of alcohols by reduction of carbonyl compounds. Now carbonyl compounds are the compound which possesses C double bond O group in the molecule. These compounds are aldehydes, ketones, carboxylic acids or esters. Now here when these carbonyl compounds undergo reduction, gives corresponding alcohol. In this reaction, C double bond O group is converted into CHOH group. Now here, two methods are there, or two different catalysts are used to convert these carbonyl compounds into alcohols. These are either metallic catalysts like nickel, platinum or palladium, or by using lithium aluminum hydride, that is LiAlH4 is also used for the reduction of these aldehydes or ketones or carboxylic acid into alcohols. Now here first we are going to see the reduction by using nickel, platinum or palladium catalyst. Now here when carbonyl compounds are hydrogenated, when carbonyl compounds are hydrogenated, that is addition of H2 molecule is carried out in presence of nickel or palladium catalyst, then here formation of alcohol takes place. Here addition of this H2 molecule takes place across the double bond of this carbonyl group to form alcohol. This is alcohol. Now second method for the preparation of these alcohols by the hydrogenation of carbonyl compound is by using lithium aluminum hydride or LiAlH4. Now here when these carbonyl compounds are treated with LiAlH4 followed by acid hydrolysis, then here formation of alcohol takes place. This is alcohol. In this way, carbonyl compounds are reduced into alcohols. Now we are going to see some examples. For example, first we are going to see the reduction of formaldehyde. This is formaldehyde. Now when this formaldehyde undergo hydrogenation or reduction in presence of nickel, platinum, palladium or any catalyst, metallic catalyst, then here addition of this H2 takes place across this carbonyl group to form HCHHOH. Now this compound is CH3OH, that is methanol or methyl alcohol. Now second example, this compound CH3 C double bond OH, this compound is acetaldehyde. Or name of this compound is also ethanol. Name of this compound is ethanol. Now when this acetaldehyde or ethanol, when undergo hydrogenation in presence of palladium, then here addition of this H2 takes place across the double bond of this carbonyl group to form alcohol. This is ethyl alcohol or ethanol. Now third example, this is acetone, CH3 C double bond O CH3. Or this compound, common name of this compound is acetone, but IUPAC name of this compound is propanone. When this compound undergo hydrogenation or reduction by using lithium aluminum hydride followed by acid hydrolysis, gives CH3 CHOH CH3. This compound is propane 2OL, or it is isopropyl alcohol or secondary propyl alcohol. Now if you observe this reaction, here aldehydes or formaldehydes on hydrogenation gives primary alcohol. This alcohol is primary alcohol. But ketones on hydrogenation or reduction gives secondary alcohol. This alcohol is secondary alcohol.